Okay, today we're going to be talking about solving one-step equations. This is the next section in Unit 2A. So if we have a problem such as x plus 5 is equal to 13, it's pretty obvious what our answer is going to wind up being. A lot of you have done this actually even in kindergarten, except for an x they had a little box there and you had to guess what number it was. But now we're actually going to do it algebraically. So this is what you need to do. First of all, make sure you are taking notes on this. You should be writing your notes there at home. We are using Cornell note style, so you have your two columns. The first thing to get rid of, or to solve for my x plus 5 equals 13, is I need to isolate the variable. That means my variable needs to be all by himself. So any number that I see that is with the variable or on the side with the variable has got to go. I use the analogy a lot of times about the slasher movies, I call them, and they have a commercial now. I think it's a car commercial or car insurance commercial where they talk about how people are tripping and falling in the woods, and that person who trips and falls in the woods, they're the one that winds up dying in the slasher type movies. So in this case, it's going to wind up being 5 that has to go. We need to get rid of him. So step 2, how am I going to do this? I need to get rid of anything that is with the variable. So I'm going to get rid of 5. 5 has to go. So I'm going to just kind of circle him to show that this is what I'm going to get rid of right here. The same thing like we're talking about circling our terms. I'm circling this to show that I'm going to get rid of this. Now, how am I going to get rid of this? What I'm actually going to do is I'm going to use one of our properties. One of our properties tells us to use the additive inverse. Because if I do the additive inverse, I'm going to add a negative 5 to my positive 5. And what happens is I wind up canceling that out. It winds up being 0. And that's what I want, because I want 5 to go away, so I'm going to add its inverse to it to get it gone. Whatever I do on the one side of my equation, I must do on the other side of my equation. The whole sign here of equals means it's got to stay equal and balanced. So if I add to one side, I have to add to the other side. If I subtract from one side, I have to subtract from the other side. So whatever I do to one side, I must do to the other side. Again, as we were talking, this right here, additive inverse, they cancel out. So they're gone. Plus 5 plus a negative 5 gives me x all by itself, because that's 0 there. So that gives me x equals. Now I have 13 plus a negative 5. That's going to give me 8. Now again, to keep in mind, this here is my additive inverse that I did right here. And also what we already talked about here, we must do the same thing to both sides of my equation. Now, most of you might recall that you've done it slightly differently in your other classes, and I have too. I've even taught it this way, where if I have a plus 5 here, I need to do the opposite, which is going to be to minus 5. Because plus 5 minus 5, again, gives me that 0. Again, whatever I do to one side, I have to do to the other side over here. This, again, cancels out, and I'm left with x is equal to 8. This right here is perfectly fine to show your work, because I have still done my additive inverse. Because if I was just combining my integers, I have a positive 5 and I have a negative 5. That's still my additive inverse being done right here. That's still the additive inverse. And that's what's important to do, is make sure you are doing that additive inverse. Make sure, please, to keep your equal signs lined up. A lot of people like to do this, where they sort of draw a line straight down, kind of a wall, to keep it all nice and neat and lined up. And again, also make sure that you are writing your subtraction of, or adding of whatever you're doing right underneath of the original number, like here and here. Make the minus 5 is under the 13, and the minus 5 is under the 5. Okay, here's another example. I have 1.4 plus t is equal to 3.6. Do not let decimals or fractions or anything like that throw you off. It's the same thing. I have 1.4, he has to go because t needs to be all by himself. So since that's a positive 1.4, I need to subtract 1.4. That's the same thing as adding a negative 1.4, but I can also just do it as subtraction. That's my additive inverse. I'm also going to subtract 1.4 from the right-hand side of my equation because I have to keep it balanced on both sides. Once I do that, this cancels out, and all I'm left with, watch your signs, again, I'm left with a positive t. And that's what I want, so I can just write t. Equals, again, keep your equal signs nice and lined up. And again, I have 3.6 minus 1.4. That leaves me with 2.2. Okay, let's do one more. This time, we're going to have x minus 36 is equal to negative 2. Okay, again, the number I need to get rid of is the number that is with my variable. The number with my variable is a negative 36 or a minus 36. So this is what I need to get rid of. In order to get rid of it, I have to do my additive inverse. So if I have a negative 36, it's going to be a plus 36. That's my additive inverse to cancel that out. They're gone. But again, if I do it to one side of my equation, I must do it to the other side of my equation. Alrighty, so now that I've done this, I have x alone on the left-hand side. Bring down my equal sign. Again, if you want to use the wall, so to speak, to keep it lined up, you can do that. Excuse me. And then we're going to do negative 2, combine it with positive 36. This is just my integers again. I have a negative and a positive, which means I need to find the difference between them. The difference between 36 and 2, I'm subtracting. It's 34. I need to watch my sign. Is it going to be negative or is it going to be positive? Remember, we're taking the sign of the larger number, meaning the larger absolute value. In this case, 36 right here is positive. Not only is it the larger number, but it also has a larger absolute value. So this is a positive 34. So x is equal to positive 34. Okay, now we're going to solve using multiplication and division. So our problem this time is 7m equals 42. Remember that a number and a variable right next to each other means we're multiplying. So that's the same as saying 7 times m equals 42. Number one, I still need to isolate the variable. And number two, I need to now use the multiplicative inverse to get rid of whatever's with the variable. Because this time, instead of wanting it to be 0, I don't want 0 m's or 0 variable. I want to have just one variable sitting there, m equal to something, or the variable equals something. So the number I'm getting rid of is a 7. So looking right here, I have 7. Again, I'm multiplying it by m. So the way to get rid of it is to use my multiplicative inverse. This is back from our properties that we were doing earlier in the year. So the multiplicative inverse means, and I've got to multiply 7 by its multiplicative inverse to make it be 1. What that's going to be then is I'm going to multiply by 1 over 7, because 7 is the same as saying 7 over 1. Remember, whatever I do to one side of the equation, I must do to the other side. So this side I'm also going to times by 1 over 7, because I can put 42 over 1, and then I can multiply those. On the left-hand side here, this all cancels out. 7 and 7 become 1. 1 and 1 is already 1. So 1 times 1 is 1. 1 times 1 is 1. And 1 over 1 is still 1. So all this is really just canceled out. What I have left is m. And that's what I want. I have m all by itself. That's going to equal the same thing as 42 times 1 and 1 over 1 times 7. Well, 42 over 7 is going to give me 6, m equals 6. So this here is my final answer. Now, sometimes though, or I should say, we know that we can do this a little bit differently. Instead of multiplying, if I had this, 7m is equal to 42. We can, again, the multiplicative inverse is the same as doing the opposite operation. So instead of multiplying by the multiplicative inverse, I can actually divide by whatever number's there because it's the same thing. It does the same thing. So if I divide both sides, and this time we are going to use the division bar that looks like a fraction bar, so to speak, we're going to divide both sides by the number we're trying to get rid of. We're trying to get rid of 7, so I'm going to divide by 7, which means I also have to divide by 7 over here on the right-hand side. This still works out the same way because 7 divided by 7 cancels out. 7 divided by 7 is 1, and that's how many m's I have right here now. I have 1 m. I don't need to put the 1 in front of it because just m sitting there all by itself, we know that's 1 m. And again, 42 divided by 7, it gives me 6. So I still get the same answer. So you can use the inverse operation. Here, we use the inverse operation. So instead of multiplying, we divided to get rid of the 7. The one that we did before up here, what we did was we literally used the multiplicative inverse. This is the multiplicative inverse. Okay, let's do another one. Again, I'm going to kind of do my Cornell notes here. Let's say we had this. This says x divided by -8 is equal to 4. Well, I have to do my multiplicative inverse if I was going to do this. Or I can just, since it's division, I can just multiply by the -8 because that's what I'm trying to get rid of. And I would use the -8 because, of course, that's what it is. It's a negative here. But also, if I'm going to go ahead and multiply this whole thing on the left by -8, because it's -8 over 1, this again cancels out, and I'm left with x over 1, which is just x. Because I can do the opposite operation. Instead of x divided by 8, I multiplied the whole thing by 8. But I need to make sure, almost forgot here, I need to make sure that I do it to the other side. It has to be done to both sides. So now this side I'm also going to multiply by -8. Watch your signs, it's got to be negative. Speaking of which, I'm sorry, let me go back to the left-hand side a minute. Remember that a negative times a negative gives me a positive. That's what I want. I want a positive x. And that's what I have down here. Just x all by itself, it's a positive x. But now I have 4 times -8. Remember that a negative times a positive is going to wind up being a negative answer. And 4 times 8 is 32. So there's my answer for this one. Remember, we're going to be working with this a little bit more tomorrow in class. But do make sure that you are that you took notes on this and that you did your best on the questions. And again, tomorrow in class, we're going to do it again and also show you using some manipulatives how to do this. Have a great night.